So as I mentioned, guys have to help me get some subscribers, man. See, I'm trying to go live and they're not letting me go live because they're saying I have too few views and too few too few subscribers. Come on, Colton, you gotta do better. Josh, come on, man. You gotta help me out, man.
So
Better help
that's
me out.
binary, isn't it? Binary coding.
Yeah,
Okay.
nice. So you're already familiar with binary.
I know of it, sir, because of Teen Titans.
Oh, gotcha. All right. So hopefully I can inform you a little bit more about it. And yeah, it should be fine. All right. So my objective today is for us to explore how sequence of binary digits can represent numbers and basically to convert between decimal and binary and perhaps vice versa. It's depending on how far we get. I want to start by first providing a definition for data. Almost everywhere I've been and I ask persons, what is data? They come up with that bad word, information. They're not the same. All right, so data is not information. It's definitely not in the context of computing, computer science, information technology, not in my field. Okay, so let's see if we can give a, a simple explanation of what data is. If I came to class and I place an X on the screen, what would you be thinking? What would you be thinking? Just see an X on the screen. What would you think? Hmm?
Can you
Just
repeat
an
that, sir?
If you came to class and I just place an X on my slide here, what would you think? Or what would
I
you
would think
ask?
you weren't keeping class and I could leave.
All right. Okay, what if I put a P up there? Just a P.
That wouldn't signify anything, sir.
Ah, that's exactly what data is. So when we speak about data, yeah, it's basically a collection of facts. We may call them raw facts, and raw facts capture exactly what you just said. We don't know because it signifies nothing. What is absent from that P is a context. It is some form of background that will help you to form meaning. If I were to then say the P stands for my middle name and my middle name was Paul, that becomes information. I have given you context, I have given you background that you are now able to use, whether it is for decision making or just simply for information purpose. That is the difference between information and data. So it is a
So
collection.
data would be the pieces of the puzzle, sir. Data would be each piece of a puzzle to complete.
Now, not really. It's just raw facts and figures. Just like if I place up here 586 and I ask you what is 586, you're not able to tell me. It could be 5 car, 5 dumpling, 5 girls, 5 boys, 5 truck. We don't know what it is because you do not have the context of it. So data is really anything that lacks context in a sense. All right. Whereas when we provide context, it becomes information. All right. Cool. So examples of data I'm giving here. All right. Look at the numbers 25, 3.14, 2025. All right. None of that have any meaning. You can speculate that 2025 is referring to a year, but I could tell you that that is my salary that I received last month. Right. 3.14, you may speculate that it stands for pi, but that might just be how long I've had how long or how tall my cup is, right? And 25, you might argue 25 might be age, but I might tell you that that is my ambition. That's what I want. I want to attain 25 cars in the next 5 years, right? So the point I'm making here is you don't have enough context. You can speculate, you can assume what it stands for, but you have no great clarity. as to what it is. So that is data. Raw facts, raw figures. Yeah, basically. Another one could have been in the context of computing. Yeah, we could treat this as Apple, but if I even show you Apple, what does Apple stand for? You know, it might be one fruit, but does it have any other meaning? Maybe it's the name of a girl. You don't know. Hello world might sound like a greeting, or it could just be a sentence. It could be a keyword. It could be a password, right? So you don't know what these actually stand for because they lack context and meaning. In the context of computing, yes, data can also be a photograph. Without adequate context, you and I have been told that a picture is worth 1,000 words because a picture can mean 10,000 different things. Without proper context, we don't know exactly for sure what it is. All right, audio can also be classified in the context of computing as data, and so is video. All right, so until we have the actual meaning behind it, they are simply data. Now let's try and put this to the computer. The computer basically stores everything, whether that is numbers, text, images, audio, video, sensor reading. It stores it as a binary number. Now, the word binary comes from the two-letter word bi, and by refer to something that refer to two, right? Number two. All right, so bicycle have two wheels, you know, yes. So that's the same context. When we speak about binary, we're talking about zeros and ones. We're basically saying that the computer uses a number system called binary as opposed to the denary, which is used by human beings. I'll talk more about that in a little while from here. Just to give you a little bit of background, if you look on that, the letter A would be stored as 010001. So when you press A on the keyboard, the message that is transmitted is 01000001. This is equivalent to the number 65 in 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 denary or in our human number understanding. Okay, so everything that is transmitted in zeros and ones. Hopefully that's clear so far. All right. So that is why we study binary, right? Because this is how the computer understands and interprets data. So today, the main question that we want to answer is how data is stored in the computer. I've already pointed out that it uses the binary representations of 0 and 1. Again, just to reiterate what I said before, all data in a computer is stored as text, images, text, images, videos, programs are stored as binary digits, just to point that out. Now, when we see zero, it's not just a number, right? In the context of a circuit, zero means off and one means on, right? For us to understand, we say zeros and ones, yeah? But zero just means that it's off and one means it's on. We're going to do some examples in a little while. Um, 8 bits make what is called a byte. You know, I tell you, you see the person who invented this was really hungry. So they thought about food. It is my assumption. So 1 is a bit, 4 is a nibble, and 8 is a byte, right? So let's say that again. 1, which may be a 0 or a 1, is represented as a bit. So a bit is the smallest amount of data or smallest measurement of data that exists. All right. So that means 1 is the smallest that you can actually get, and that's referred to as a bit. But 4 of those bits make a nibble, and 8 of those bits make a byte. Here's my question. How many nibbles make a byte? Where's my school challenge quiz people?
Sir?
How many nibbles are in a bite?
Sir, two?
Nice. Good, fabulous. Y'all are getting into the computer language. So in terms of larger numbers, right? Let me use an analogy to help you understand this, right? Um, when we're measuring a ruler, a little piece of stick like this, we use centimeters, right? But when we are measuring the road, we use kilometers or maybe miles. Why don't we measure the road in centimeters?
Sir, it's not practical.
Why?
It's too short a unit.
Is it too short or something else?
It
The
would take
number,
too much time.
the value would be too large.
Thank you. The value is too big. Just imagine trying to communicate 200 miles in centimeter. How large that number couldn't hold on the page. So this is why they had to come up now with larger units so that they can represent data. So all we're saying here is that if we were to measure everything in bits or bytes, after a while, it would just be too big in terms of a number to keep track of. So once we get to 1,000, we refer to that as kilobytes. Now, the exact number is 1,024 bytes. So 1,024 bytes is equivalent to 1 kilobyte. But for rounding off purpose, you will hear people say 1 kilobyte is 1,000. I want you to know that for the purpose of actual details, it is 1,024. For the purpose of your exam, your level where you're at, you just need to remember that kilo means 1,000. I'm speaking about 1,000 bytes. All right. Obviously, if there's a situation where you need it's a paper to answer and you need to explain it more in the details, then guess what? You can of course refer to 1,024, but maybe in a multiple choice question what you'll see is 1,000 and not 1,024. All right, very same thing with megabyte, MB, megabyte. How much is that? Forget the 1,000 kilobyte here. How much is a mega? What's mega? What do you think mega stand for? Mega. Come to the people them. What's mega stand for? If kilo is 1,000, mega is a the class asleep on me today. Come on, guys. Hmm?
1,000, sir.
If kilo is 1,000, then
Oh, oh, oh,
mega
oh, oh.
It's 100,000.
100,000. No, so that's too small.
Huh.
Let me see who is in the chat. All right, a million. Right. So it's a million. All right. So when we say that your phone have 3 megabytes, right? What we're saying is that your phone can store up to 3 million bytes of data. Okay, that's what that means. And of course, um, a megabyte is still equivalent to 1,000 kilobytes. Remember that 1 kilobyte already means 1,000. And so 1,000 times 1,000 is a million. All right, cool. So what would GB, gigabyte, what would that be?
A billion.
Very good. So that would be a billion. And it is the same as saying 1,000 million bytes, which means 1,000 times a million gives you a gigabyte. All right. And TB, anybody know that one?
Trillion.
Trillion, right? And TB stands for terabyte.
Terabytes.
Good? Yeah. So that would be the same thing as saying 1,000 gigabyte or 1 trillion bytes give you that amount of data. All right. So which of them is the largest?
Terabyte.
Good. And which is smallest?
Kilobytes.
Somebody in trouble, You don't have nothing less than 1,000
Bits.
Sir, the
bit.
bit.
Bit. There you go. All right, so bear that in mind because I've seen this as an exam question quite frequently. What is the smallest measurement of data? And that's bit, all right? There's obviously bigger than TB. There's PB, which is next, which is petabyte. And we could go on and go on, but you don't need to know anymore at this point. Cool. Um, so let's go back to a question, something I showed you earlier. Let's quickly go back there. So let's look at this now. How many bits make the letter A? Come Jade, man, talk it, speak it.
Sir, 1.
How many bits make the letter A? Come on. Can't be 1.
Sir, 8, sorry.
8. Good. And 8 bits is equivalent to what?
1 byte.
1 byte.
So every letter that is out there will make consists of 8 bytes, all right? And that is using a conversion system called extended ASCII. ASCII uses 7 bits, but extended uses 8. We'll talk about more of those. I'm just dragging into the conversation so that it start making sense. Don't run away yet. Taking our time. Now, since I'm talking about data, I need to mention these 2 words because from time to time you'll see them popping up on your exam curriculum. Discrete data. All right. Since we spoke about data, let's now talk about what discrete data is. How persons are making their own notes as you are traveling. All right, cool. So discrete data can take only specific separate values, usually whole numbers. We're going to look what that means. Most times, discrete data cannot be divided into smaller, meaningful parts. I'm going to give you some examples. So the number of students in a class, that's a whole number. That makes it discrete. If we were to try and divide 25, we'd probably get 12.5, and you're not possible to get 12.5 students, is it? Right? But so whole numbers are usually classified. So one of the rules of it is that whole numbers are classified as discrete data. Because we have 25.5 here, it is what we call continuous data. All right, so just to point that out as a difference. So the number of cars in a parking lot would give you a whole number. You're not going to get 16.5 car or 12.5 car. All right, cool. Let me ask, Colton, what do you think age of a student would be? Is that discrete or continuous?
Discrete, sir.
Yeah. So me can be 12.5.
As Jade said earlier, it's not practical.
To be 12.5? Then what if
We
me live
don't we don't say
12 years and 6
someone is
months?
12 point. So we don't say someone is 12.5 years old. We say they're 12.
Yeah, good. All right, so me is just arguing with you to make sure that you are solid in your explanation, and that's right. Good. All right, so number of books on a shelf, I don't expect to get 2.5 books or 3.5 books. So that would be classified as discrete data. Shoe sizes as well in some categories, right? So let's just say categories like, is it large, is it small, is it medium, or is it 12, is it 11? I'm sure that there are some system, I think in the UK maybe, where you might have 12 and a half, 3.5. Just know if it's a fraction or a decimal, it is continuous versus if it's a whole number, right? So here are some key points you need to take away when you're trying to find out what is discrete data. They must be countable, all right? Something we can count. I can just go out there and count it and get it. What do you think height of a table would be? Is that discrete or continuous?
Continuous, sir.
Lovely. We can't count the height. We don't count height. We're going to measure the height, right? So that's the difference, right? So continuous is usually measured, whereas discrete is countable. There's also no fractions or no decimal. So that's what you want to remember. And of course, if we were trying to measure it on a graph, then you'd put that on a bar graph because they are set numbers, right? So that's something you want to bear in mind as you think about the difference between discrete and continuous data. Just to reiterate continuous data, it takes in any value that is within a range. It can include fractions and decimals, but here's the key. The values are measured and not counted, all right? So that's one of the biggest key there. And again, I tell you, anytime I bold something in my class, it's something you need to remember. It's key information. So examples, all right? Height as mentioned, is you don't count the height, you measure the height. And it's likely that sometimes you may get a decimal. Weight, no, you don't count the weight. You have to weigh the person or weigh the thing to get the value. Temperature as well is measured. It's not nobody not just get up and count the temperature. So Jade going like she cool, when you just get up and count the temperature. We'd have to get a thermostat to go in and measure the temperature, so to speak. All right. Time again. Nobody not count the time. We use a watch to check the time, right? And therefore that in itself is continuous. So here are some key points that you have to take away. Continuous data is measurable. It is infinite possible values within a range. Because even though you see 1.654, that might be 333113300556666. Just round off to 1.65.4, right? That's what we mean. And then in terms of graphs that you would want to represent this on, it would be like histograms and line graphs. So more than likely, if they gave you an exam and say which of the data you would be most represented by a line graph, obviously you know that would be continuous data. Right? Sound good? Body all right? Good. Now
Yes, sir.
we are going to have a discussion now. So you know, and I don't like use people money. So me make up my own money, and my money name Boins. All right, cool. I want you to look at my points because that is all the points I have. And I want you to tell me if there's a value. Tell me a value that I cannot pay for with my points. Or what is the highest value that I cannot pay for using my points? What is the lowest value, I should say, sorry, that I cannot pay for using my points? And not no self is zero, free that.
0.9.
I want to talk about, man. Listen, no, the lowest, I free that. Not go under no, not selfie under $1. What you talk about, man? In Jamaica, you can't even get nothing for under $500. What you talking about?
A bag juice, sir, $50.
All
10
right,
bag
so,
juice for 500.
oh, cool. Chat board. You know when I go to school in Jamaica, which is not many years ago. I don't want to sound old, but patty was being sold for $12, $11, sorry, $11 when I was buying patty for high school.
That economy sounds great.
Come now, people, talk to me now, man. What is it that I cannot? What is the lowest amount, and it's not zero, that I will not be able to pay for? If these are my boins, I have a 4 boin, a 1 boin, a 8 boin, a 2 boin, and a 16 boin. What can I not pay for? What is the lowest amount? And that is not zero.
3,
Which one?
3.
Free? Then not three that. What you talk about? 2 plus 1, not three that. You talk about? Pay for that. 2 plus 1 are 3. that pay for. And the people in my count up my money, man.
Sir, $32.
$32. Yes. 32. Let me see if not no lower than that. 16 plus 4, 24, 28, 30, 31. Yes. $32 is what I cannot pay for. Now, you know what this process is called? It is actually called sequencing. All right, this is called sequencing. Sequencing is when we have to put different values together to meet a certain new number or to represent a new value. So let's look at this. Like if you were selling something for $1, I have something to represent that value. If you were selling something for $4, I also have something to represent that new value. But if you decide to have something selling for $8, I have something to represent that. If you are doing two, I also have something to represent that. And if you had something for $16, I definitely had that. But look at this now. When it came onto three, I didn't have anything over here to represent it, but I could join two things together to represent that new piece of data. All right, which is how we use in our number system at the moment. When you go out there to buy, what are different money you have in Jamaica? 5,000, 2,000, 1,000, 500. You still have $50?
Yes, sir.
Now $50. Cool. So that means if I want to buy 10,000, something that is valued 10,000, you don't have any money that can represent 10,000 by itself. So you have been engaging in something called sequencing. You have to join two of your $5,000 to now represent that new piece of data, which is now $10,000. You are going to see how this makes sense in a little while. All right, cool. So make we go on. All right. So as I was sharing earlier, same thing with $13. Notice sequencing. I don't have anything on my thing that is 13, but I can join three of my value to pay for that $13. Same thing for 26. I can join 16, 8, and 2 to get me 26, right? Okay. So what we are saying here, this is called sequencing. A sequence of decimal number represents a number. Let's try and put this now into our language, right? We use a number system starting with D. You call it decimal, but I will call it denary. That's a new language you're learning today. Denary, okay? Now, in decimal, how many numbers do we have in decimal? How many numbers do we have in decimal? Pam, panam, pam, 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 panam.
9.
It's not 9. It's close, but
Infinite,
not 9.
sir.
Infinite.
8.
No, sir. Look on the screen, people. Come on. Look at my screen. I can't believe it. I'm going to call your principal bright and early tomorrow morning. How many numbers humans use? How many? Nobody now look on my screen. All right, come make a count. Come,
10.
count. Who said 10? Good. 10 is the answer. Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9. You do not have another character that represent a value greater than 9, a single character. So in order for you to represent 10, you also have to use something called sequencing. You take a 1 and a 0 and say that is now 10. When you get to 11, you take a 1 and a 1 again, and you say that is 11. When you get to 12, you do the same. You take a 1 and a 2 to represent that new value. Call it 12. Am I right or am I right?
Yes, sir.
Thank you. This is why we call decimal base 10, because we represent everything within 10, because we only have 10 characters. All right, cool. Let's see if we can run along. So let's look at this number again. You call this 42, but the real reason why you end up with 42 is because you don't have a single character that represents this value. So you have been engaging in something called sequencing. You take four what? Four tens and 2 ones and put it together and say 42. Am I right or am I right?
Yes, sir.
Yes, sir.
All right. So make go on with my computer now. Not do that. Come off of that. uh where's my sorry guys, my computer just kicked me out. No, I have no manners. It's out of order. All right. There is my work. Say, computer now have no manners now. Look how long me I grow you. No manners. Just kick me out like that. Not even say, sir, may I close because I'm getting frozen. You know, say, is Jade carry the cold business come over here? All the computer get cold. So, computer get cold and shut down. So, man. All right. Down. All right, with the boy, yes. All right. Cool. Come back up now. There you go. Yeah. All right. Cool. So, what I'm doing now is taking you back to what you would have learned in grade 1. It's just that when your teacher was explaining, probably didn't relate it to computers and people. All right. So people use a number system called denary slash decimal or base 10. We name it base 10, yes, because it has 10 digits. All right. So 10 digits. Cool. So we have ones, tens. What come after tens? What come after tens? Hold on, now many people them there.
Hundred.
Hundreds, then
Thousand.
thousands, then
Ones.
10,000.
10,000.
10,000, then
100,000.
And then
1,000,000.
1 million. All right, same thing. So I want to refer to these things up here as my multipliers or my weights. Why? Because that's what I multiply the actual value by. 4 times 10 will give me 40, and 2 times 1 will give me 2. Put that together, I end up with something called 42. Let's use another number. 314, made up of 4 ones. These are my weights. And then tens. That is my weight. So 1 tens, and this have 3 100. 3 100 gives me 300. 1 10 is 10, and 1 4 is 4. Join that together with 314. We do the very same thing when we get to bigger values. We have 8 ones, 1 tens, 7 100, and 2 thousands. We put all of that together, we end up with 2718. Now, you may be sitting there and wondering, but what does this really have to do with IT? Let's see, we're getting there. So as I mentioned before, we use 10 digits and the decimal or base 10 system, same thing. So if you hear about denary, decimal, or base 10, it means the same thing. It means people use 10 numbers, all right? Every piece of numerical data that we have is represented by using a sequence of these numbers. So if I have 902 that I want to represent, it means I need to get 9 tens, 0, 10, sorry, 900, 0, tens, and 2 ones. All right. So this is probably, and this is my assumption, that the first man that used to count, Jade, did only have 10 fingers. How much you have, Jade? 11? You have 11? See if we did have 11, man. Yeah. Yeah, you see, if you did have 11, would have moved beyond 10. But I believe that the first person wanted to represent one, he had one finger. He had two fingers. But when he got to 10, yes, him just realized, listen, we have to come up with some sequence to represent these new data. So how does this relate to what I am doing? Because the computer actually uses a different number system, which is called binary or base 2. Let's go back to denary. How many numbers are in denary again? How many digits are there?
10.
10. Very good. So how much is in binary now?
2.
2. Excellent. Which means you have to think about human beings as somebody from France and computers as somebody from Jamaica. They speak two different languages. They refer you refer to this number as 2718, and the computer is definitely going to represent that using zeros and ones. So we have to then come to a place where we learn how to convert between the two. All right, so let's go. So these two numbers are zeros and ones. We call them binary digits. Now, do you see where we get the word bits from? Bits is actually the shortened form of binary digits. All right, got it? So we get bits from binary digits. So when we say 1 bit, we are still saying 1 binary digit. 8 bits, 8 binary digits. 4 nibbles is still 4 binary digits. Am I making sense? Everybody with me?
Yes, sir.
Yes, sir.
Good. So because they only have 2, so the computer did only have 2 fingers. After you reach 3, the computer has to embrace something called, what is the word? What is the word? What is the word?
Sequencing.
Sequencing, which means they are going to have to use 0 and 1 to represent new values. All right, so let's go for a practice. This is very similar to what we would call our placement value. Ours would have had ones, tens, hundreds. What do you think now? So this one will start at 1, but because how many numbers are in binary?
2.
That means we have to multiply by 2 across to get the new value, which means if the first one is 1, this is the weight, that means this one will be? Why is my class falling asleep? Let's ask again. Make we go back to human people, because everybody now listen to me, so let's go. When the human them did that, how many numbers in the human number system? How many? How many
10.
digits? 10. So that
10.
means 1. 1 times 10 is?
10.
10 times 10 is?
100.
100 times 10 is?
1000.
And then 1000 times 10 is?
10,000.
So that's how they get their placement value. So let's find out how the computer get its placement value. So 1 times 2 is?
2.
2 times 2 is?
4.
4 times 2 is?
8.
Very good. The rest of them must put their hands together for Colton. Well done. So in that number system, it is base 2. not base 10. All right. So if we wanted to figure out what is this value, what is 1001 in denary, we would need the weights. So let's go. We're going to multiply up. So 1 times 8 is? Wait, people in there.
Repeat, sir.
1 times 8 is?
8.
0 times 4 is?
0.
0 times 2 is?
0.
And 1 times 1 is?
1.
So 8 plus 0 plus 0 plus 1 is?
9.
9. That means in the computer language, the number 9 is 1001. All right? Everybody see that? You see? You see? So you said 9, but in binary, the number 9 is 1001. Everybody get that?
Yes, sir.
This is how we convert from binary to decimal. So we're going to do one next one. All right? We're going to do one next one. I wonder who can tell me what this value is. I mean, now going to know weights, you know. I want to try for myself. Yeah, I mean, want the school challenge quiz style. You know me, I watch school challenge quiz and be the match. We need it school challenge quiz style. You know it go already. Anybody with the answer? Anyone with the answer? Anybody? Come on, guys. First thing you need is your binary table. 1 times 2 is?
2.
2 times 2 is?
4.
4 times 2 is?
8.
8,
And 8 times 2 is?
16,
And then we're going to multiply upwards, which would mean 1 times 16 is?
16,
0 times 8 is?
0,
1 times 4 is?
4.
4,
And 0 times 2 is?
0,
0.
And 1 times 1 is?
1.
1,
That means 16 plus 4 plus 1 is?
21.
21,
21.
21. Like we see if we're right. All right, so first thing you do in doing this is to count up the amount of binary digits you have. That's 1, 2, 3, 4, 5. Let's create a little table. And then at the top, you work out what the weights are. The weights start at 1 and you multiply by 2 across. So that's how we get 1 times 2, 2, 2 times 2, 4, 4 times 2, 8, and 8 times 2, 16. Once you have done that, the next step for you is to multiply upwards. 1 times 16, that is going to give us 16. 0 times 8 gives us 0. 1 times 4 is 4. 0 times 2, 2. 1 times 1 is 1. And from there, we end up with 21. Are there any questions? Anything not clear? All right. I see him on this. No. Yeah. Question.
Sir, I was going to ask you to switch back to the slide, but you did it.
I did it already. All right, cool. So may I give you one more? Let me see you try this one now. So can you figure out what value this is in denary? The computer understands it as 11010.
26.
You are saying this is 26. All right, cool. What the others saying?
$26.
26. All right, cool. Everybody look like in concept. Me like that, man. We try work it out now and see if we're right. So again, same thing. Create your weights at the top. One times so two times so four times so eight times so 16. I also want to make sure you realize that we always start from the rightmost corner, which means the number on your leftmost corner is the largest number. If you were to have started here, chances are you'd be wrong. So please make sure that you note that for me. All right, cool. Now, the next thing that we do from here is that we are going to do our multiplication up. 1 times 16, 16. 1 times 8, 8. By the time you reach here, so after 3 of them, you realize that anything where 0 is always going to be 0. So you're not even have to bother work that out. You just need to work out the ones, all right? And then add them together, which means 16 plus 8 plus 2. And I agree that that is 26. Fabulous work, guys. So here's what I want you to do for me. In your own words, I want you to write down how do we convert from binary to denary. In your own words, I'm giving you a minute to write down steps. Tell me steps in your own words how to convert. And I want you to do it like you're talking to a 5-year-old who don't know nothing about this, but them bright enough to hear what you're saying. So make it quite detailed and clear for me. I'll be asking you to share your answers in a little while.
Sir, from binary to decimals, right?
Yeah, from because that's what we've been doing all along, binary to decimal. Okay. All right, cool. All right, Kaniva, can you go ahead and do your explanation? Tell me, how would you convert from binary to decimal? Is Kaniva there? All right. How about Rajin? Rajin, you there? Nope. Ashney. No, sir. My class gone.
So what I have is multiply each digit by
Each digit.
Right, look like
Multiply each digit by its corresponding power of 2 and then add all of the results together.
yeah. All right. I go here, Josh. What is your thoughts, Josh?
Sir, let me go back. Starting from the left, multiply each digit by a multiple of 2, starting at 1, then add up each sum. Yeah, it's
And no, me not hear about multiplying upwards, you know. So, I know. What about Jade? Tell me your explanation.
We would start, basically, sir, we would start
Mhm.
multiplying, as Joshua said, from the left. Well, no, not from the left, from the right. Sorry. So we'd multiply from the zero over by the left over to the right. From the right to the left, sorry. And then multiply, do that kind of multiplication, then addition at the bottom and get your decimal, number, whatever.
All right, cool. We have to work and make sure to explain it. All right, cool. If I was answering it, this is what I would say. All right. I would create a binary table. We know nothing a table as because I do it stylish, but I'll create a binary table and I would work out what the weights are. So to work the weights out, this is where I would now start by talking about from the rightmost value, we are going to start with 1, then multiply by 2 across to get the next one until we get to the end of the binary digits. Cool? From there, we will multiply the actual number, binary digit, yeah, the actual binary digit by the multiplier or the weight, and that would give me a certain value. Then I will add them across to get the final value. All right. So try and remember that. So this is supposed to be like a table, best way to do it. And then this part, I call them multipliers or the weight, whichever you remember easy. Remember, this is your actual binary digit. So you're multiplying your binary digit upwards, right, by the weight, and then adding them together to get your final answer. All right, good. So um, I wanted to give you a task to quickly do. There is a worksheet on the Google Classroom. All right. Can I ask you to go to that or open that just now? That's what it looks like. So if you can't get on there, just work this out. So what I've given you is a simple table with the weights at the top here. And I want you to work out what these linear numbers are. So what is this one? What is this one? And what is this one? So if you can't get to the worksheet, just do it on piece of paper or whatever you're doing, and then tell me what the answers are. So tell me what is 10, what is 110, what is 1011, and what is 10010. Okay, let's see if we can get some answers. So first one is
2, sir.
2. Okay. What me now give me answer? Don't give yes, cool. What is the next one?
6.
6.
Next.
11.
11,
Hmm. Next.
18.
18.
18.
Nice. Good, guys. Well done. Proud of you all. All right. So here's one now. I have another task for you. I hope it has show good enough. It's also on the site. Let's see. How old is it? All right, cool. Yeah. I want you to look on this and try and work this out. All right. So giving you a little bit of style. You have a friend who loves binary numbers. You ask her when her birthday is, and she writes the following on a piece of paper: 11001 and 1100. So this is the day and this is the month. All right, so work this out for me. So which day is it? Which month is it? And then you ask her how old she is, and she draws a birthday cake with binary candles. So the ones that are lit are ones, and the ones that are not lit are zeros, which means they are off. So work out those 3 for me, please. Nice, Katrina. Yep, seeing your answers.
So what did you say the lit candles represent?
So the ones that are lit are on, are 1, and the ones that are not lit are 0. They're off. So I want to know which day this girl that you keep asking her birthday. I want to know which day she born, which month she born, and I also want to know how old she is.
Finish, sir.
Finish. All right. So let's hear what the answers are now. So yep. So which day was it? When is her birthday?
December 25th.
December 25th.
Christmas.
All right. Good. December 25th or the 25th of the 12th. Great. And how old is she?
18.
All right. Cool. 18 mean too old. Let's go on. Next, so we're going to move on to this bit. So I think persons would have generated the understanding of converting from binary to denary. So we're going to do the opposite around here, okay? So the same thing, this time we want to move from decimal to binary, all right? Decimal to binary. And this time around, you need a table. So think of this as a table. And the table again, we start with the rightmost corner. And again, we start with the number 1 and we multiply by 2 across. 2, 4, 8, 16. We are going to put ones under each one that we can get from out of 13. And we're going to put 0 under the ones that we can't. All right, so let's try and do this one together. So hear me. Can we get 16 from 13?
Sir, can repeat.
Can I get 16? If I have $13, can I buy something for $16?
No, sir.
No. So because of that, we put 1 or we put 0. Which one?
0.
0. Good. So that means that becomes 0. So we still have our $13. Can I buy something that's for $8?
Yes, sir.
So we put what number?
1.
Good. So when I take away 8, because I spent my money and bought something for $8, how much am I left with?
5.
$5. Very good. Can I now get 4 from 5?
Yes, sir.
Okay, so what do I put, 0 or 1?
1.
Very good. Now I take away 4 from 5. I'm left with
1.
good. Can I get 2 from 1?
No, sir.
So we left with
0.
very good. Can I now get 1 from 1?
Yes, sir.
Very good. All right, and 1 from 1 would have given us 0, so we are finished. So this is how you convert from decimal to binary. So the answer would be 01101. All right, but I understand that. Do you want me to go again? All right, let's try another one. Let's do this one. Okay. Can I get 16 from 22?
Yes, sir.
So we put
1.
All right. 16 from 22 leaves me with how much?
6.
8.
6. Okay, so we have 6. All right, can I get 8 from 6?
No, sir.
So we put
0.
very good. All right. So not my value doesn't change, so I move across. Can I get 4 from 6?
Yes, sir.
So we put
1.
good. 4 from 6, we're left with
2.
2. Can I get 2 from 2?
Yes, sir.
So we put
1.
2 minus 2 is 2 minus 2.
0.
Can I get 1 from 0?
No.
So we put, what do we put here?
0.
Good. So that's 0. So the answer then would be 10110. Good. Any question? All right. No question then. So I want you, first activity on here, this is also on the worksheet, but you can do it on your book. I want you to work out what is 16. So you need to put a 1 under it if you can get it, and a 0 if you can't. All right, so work out what's 16, work out what is 19, work out what is 23, work out what's 30. And let's try and go through them.
Finish, sir.
Finish. All right, cool. All right, so let's go through them. 16, what did you get?
1 0
One
0
zero
0.
zero zero zero.
Yeah, 1000. Let's see. Yeah. All right. What was 19?
1
One
0 0
zero
1
zero
1.
one one.
Okay.
Yeah. What about 23?
1 0 1 1 1.
Good. And 30?
1 1 1 1
One one.
0.
Nice. All right. So everybody's supposed to lock down these two conversions, so that next week when we come and we decide to do some addition and we do some sign and some other little things, everybody hot. So how about this one? Let's give you some more work to do. All right. So you're going to work out 3, 4, 5, 6, 7, 8, 9, 10. I've already worked out 1, 2, 3 for you.
Sir,
Yep,
if we had a 32, would we have uh, one of the headings for that?
we would. Now, normally, and I'll tell you why we don't go more than 16, because all of these numbers are smaller than 16. So it would be 0.
Okay.
Got it. But if we were representing bigger numbers like 35, well, definitely you would need to have 32 here because it would be 16 times of 32 and so on going up. All right.
Yes, sir.
Cool. Okay, okay. Let me know when you all finish.
Finished, sir.
You're done. All right, cool.
Yes, sir.
All right, so let's go to 4. What would be 4?
1 0
1 0
0.
0.
Yeah. When me something this. Let me show that my answer, yeah, man. Show man. All right, cool. All my answers on there. So check your answers. With what you have. So yeah, 4 would be 100. So in decimal, when we are counting to 11, we would say 1, 2, 3, 4, 5, 6, and so on. Come to seize it as this: 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Okay. 4 of this is what again? Nobody remember? 4 binary digits is? No, sir. Class, no,
A
no.
nibble.
A nibble?
Nibble. Good. And 8 of them is a?
Byte.
bytes,
And one is a
bit,
very good. 1,000 byte is
Kilobyte.
1 million byte,
Megabyte.
and 1 billion bytes.
Gigabyte.
Gigabytes.
1
Gigabytes.
trillion byte,
Terabyte.
1 terabyte.
1 terabyte. All right, fabulous, guys. I think we have done fantastic this evening. So I am going to move back to doing some programming, is it? Because I think that I don't want to do too much binary on one day and people brain leave them. So I want you to just remember now that remember how to convert between binary and denary. Next week when you come, I'm going to do addition. I'm going to do sign and magnitude. And if I have time, I might do BCD as well. Following week after that, we may do octal and hexadecimal. So there's quite a bit of conversion coming up in the couple of weeks. So this is just wetting your feet in there and getting going. All right. So I'm going to use the rest of the time, but this time I want to see how well you guys can program. Because last week we given a homework and nobody not do it, you know, nobody, only one person. I'm now call the person name. So go back to, if you go onto the Google Class notebook in the section that's labeled how data is stored. So there's an activity in there. There's a worksheet in there that we just covered in class today. So I won't give homework where that is concerned this time around. But definitely I will do the programming worksheet. So the programming worksheet is what I want you to try and do today for the rest of 45 minutes that we do have left. And then once those are completed, depending on how quick you're done, we move on to something else as usual. So if you go to Trinket, Trinket, you know what? Use a different next thing. They tell me it's full. Oh, let me know if you find the worksheet. Have you found it?
Yes, sir.
Cool. All right. So I promised you last week I was going to give you guys some physics because somebody told me they did physics. So I decided let's incorporate physics in our class, yeah, man, because I think that will help you. For those people who love it and those who hate the subject will also love the subject because you have
Sir,
to use.
question.
Mhm.
Where exactly does physics come into this, sir? Can we not leave physics alone?
and sir,
Subject.
physics is fun for now, you know. For now, I like physics for now.
Or
But I
no,
don't think doing it in coding will be.
I don't think we need to put
Yeah,
and physics together.
yeah.
Like
Coding and
it
physics,
should
I
be
don't
a
think that's a good match, you know.
separate, you know?
I
Mm,
happen to think otherwise. I just think that when you can relate, it makes it more. I mean, your teacher is going to love me after today. let's do one of them together. It's the same principle we're going to apply, is it? So let's go. Let's do one together, man. Come on. All
Sir,
right.
the first
So
question.
again,
The first question, sir,
oh, you say it's hard. I look
is
good.
sir, I
what
can do this, but without the programming part.
yeah.
Right. Like it can be done without the programming.
No, Oh, no, we want to build the system. You see, as programmers, we don't just want to do it because we bright. We want to build a system that students don't have to learn this anymore. They just write in their values and it work. All right, let's try and
Leave
do
that
the
for
first.
someone else, sir.
No, we're gonna
Leave
do
it
it
for
together.
someone else.
Let's try and do the first one together and let's go. So write a program that calculates the force acting on an object using second Newton's law. Here's a part you need to pay attention to. You're gonna ask the user for the mass and also the acceleration. Then they tell us how to work out the force. So let's try that one together. All right. I'm gonna do it the easiest way this week, and then next week I'm gonna step it up and we do a little bit more than we normally do. So maybe we should start the new way. I don't want to start the new way, just the easy way. All right, let's do.
Let's
So,
do it. No way.
no way. So mass is equal to. So can the mass be decimal?
Yes, sir.
Yes,
So
sir.
what data type do we need? Float, int, or string?
Float.
Float.
Good. So input, and here we're going to tell them to enter. Oops. Enter the mass. That. What else did they say we need to ask them for?
Acceleration.
The
Acceleration.
acceleration.
Cool. So we're going to do ACC. And can this be float, int, or integer?
Most times it's an integer. It's a whole number, so integer, sir.
Acceleration. Actual.
When I do it in physics, sir, we mostly do whole numbers.
That may talk about. I think I input. I think it can be decimal. I don't know. Just face it. All right. So we'll do enter the acceleration. All right. Cool. And what do we want to find again? The
Force.
good. And what did they tell us to do? Let's look at the question. What did they say we should do to find the force?
Mass times
Display it in
acceleration.
newtons.
Very good. So all we're going to do right here, so I go mass multiply by ACC, right? Because that there. From here, we're going to do our print. The force. I'm going, man. So the force is, I tell you, I went out of my way to learn physics just for you all. I can't believe it. All right, so let's say it was 2 and 3. The force would have been 6.0. Cool. All right, so you guys can do that and then snip and put it on your worksheet. Make sure you're doing it on the thing, put it on there. Or you can just copy the correct code. Either you take a picture of it or you copy it and paste it in the box on the lesson. So we know that you have done it. All right. Cool. That's why I keep track of what you guys are doing. So please make sure you do that for me. Yeah, thank you. Then I want to try and do this one now. Right? So just look what they ask you to enter. Same thing, this time force acceleration, and you see the format. Right? So we're only applying the same principles that we have learned in this class to other areas of life. Everything that you see, Colton, is computer science. All right, everything. We build those systems to make them work. All right, cool. And I think after today, you will never forget how to calculate force or mass again. Just
I'll
because
do that in physics, sir.
you don't do that in the physics.
No, I said I'll remember it when I do physics. I'm not sure about this.
Oh, you'll reinforce it. Don't worry. All right, so try and do this other one for me. This time around, you're going to allow the person to enter the force and the acceleration. And remember, you want to display the mass, so that means you have to calculate the mass. And then we try and do this one down here. All right, so let me see. I want to take that on, and let's see. Tap, 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 tap. If you're struggling on any, feel free to let me know. Nice. All right. Nice, Josh. The only thing I'd encourage you to do is to sort of let your variables a little bit more explanatory. And I'll tell you, in the future, if you should do more complex program like so back in the days, you used to have to do one for the SP. I think you'll do one in this for SP as well. So that program is going to be much bigger than just 4 lines. When you have your variables well named, it helps you to remember what they stand for. Right. So that's something I'd encourage you to do as much as possible. Make sure that you name them as clear as you want. Also, you have an extra comma in line 4 after you print the mask out. I don't think it will give you an error, but that's an extra one.
Sir, it's the last command I need alone.
So you see after, so the one that is the last comma in that shouldn't be there. You just need, because the comma is joining the string, which is a part in red to the variable. So you only need that when you're joining two things together. All right, cool. Let's look what's going on over here. come through Jade, new programmer from Westwood. All right. This works, Jade, but me not like the shortcut. I prefer you to work out the mass. So in line 3, just do mass equal force of acceleration, and then print out the sentence at the end. The reason is I'm trying to prepare you for your SBA. In not too long from now, I'm going to give you the coding part of your SBA to start doing. So you want to kind of like practice those simple things so that when the harder things come, you're still good. All right, cool. All right, so for your SBA, you need to be able to do simple programs like this. You're going to need to know how to do lists. You're going to need to be able to do loops, while and for. I think you need at least, to get the full marks, you need to do one while loop, one for loop, and you need to be able to do if-else statements. That I can teach you in just 3 weeks. So that's fine. But just make sure you reinforce these bit of it for me. All right. That's why I want to by the end of this month, I want to get you a good point with programming, so that we can probably start looking at some Excel details. And then I can actually ask you to start working on the SBA aspect of your, start the Excel aspect of your SBA. Because I normally try to teach you a little, enough for you to start doing something and then tell you to go ahead and do it so you can work in your own time. All right, cool. So that's coming up.
Is that better, sir?
I am going to look at it right now. I do it. Why does it look like I got the same thing? Gave me the same thing. Let me see let me show you what I'm seeing. That's what I'm seeing. Is that what you sent?
Kind of, sir.
So that's why I'm saying for this part, practice to store it in a variable. So since they want us to find mass, the method you did would have worked, would have printed, but in terms of scoring the full points on your exam for the project, the SBA project itself, you want to make it as detailed and clear as possible. So better to practice this style of writing. Plus, it makes it simpler in the future. So this is the standard that I would love to see. All right, cool. All right, come on, guys. We need to complete those little programs. Let's get them going, all of them. Because I want to create a program in the end that works out the binary that we just did, And I want to do a program that does it, I don't want to come here and just have to work it out myself every time. Nice, Adam. Yep. So great. So I'm seeing that. Cool. All right. Okay. Great. Once you have done that one, guys, move to the next one on the page. Try and do that one, velocity and all those. Oh no. Problem 3 is the what? Acceleration. Let's get another one. All right, so let's get this one. All right, nice, Reggie, Regine. Yeah, got that. Uh, Ooh. All right, righty. How's it going? Everybody's good? It's getting it's getting all dark in my neck of the wood. How's it going? Everybody's all right? Working your way slowly to greatness. 101. No, that ain't right. Are we done? All done? Does silence mean consent? Are we all done?
No.
How far are we at? How far are you, Josh? Colton, how far are you at? So guys, I've made a little program that works out my binary, my decimal for me. So See. All right. So if I enter 10111, that will tell me that's 23. Right? If I enter 111, that should tell me the value is, see, 111. Yeah, 31. All right, cool. All right. Yep. right, everybody doing all right? Any question? Anything? Anything that's not working?
Sir,
Yep.
I am having trouble with the comma.
Which one? You send a link to me.
Yeah, I just sent it, sir.
Split it up and let's look at it. Okay. All right. This is one. Okay. Ask him to enter that. That's fine. So because we're working this out, do we really need to put float here? Because this is already float already, isn't it? So we probably don't need that because the float is converting the input to a decimal number already. So by the time it gets here, it doesn't need to be converted again. It's already there. All right, so let's look at this now. Which means that maybe I don't need this extra bracket here. So what is this? This is the meter per second thing you're printing. So the distance is that meter per second. Good. See, Josh, is fine.
Oh,
Yeah, there. there's no real issue. I think the main thing I took out was like the float here, because you already converted already, so you didn't need to convert again. But everything else look all right to me. All right, did anybody have any other program you wanted to show me before we wrap up today? All right, guys, send me some programs. Send me some programs. I got 4 minutes. Send me some programs now. Give me some programs. Let me see what's going on. Send me some links so I can see what's happening for the next 4 minutes.
Sir, I sent it, but I'm having some trouble with the final answer.
Okay, that's cool. We'll look at it and see. Well, it's not defined. Where's the rest of the program? Where's the input stuff? I'm only seeing one
Wait,
line.
I think that's the wrong link, sir. Give me a second.
Okay, cool. Where's Jade? Adam? Janobi? What's going on? Send me some programs. Send me some programs. Don't be making me make up no noise on the people on Saturday evening. Send me some programs, man. All right. Good. Let me be getting some programs now, please. Thank you. All right. So this one is the mass one I'm seeing. Adam, did you move on from here? Remember, you needed to do the other worksheet. So that one is good. Let's look at Colton is sending me more program here. Let's see. Velocity. What was the formula again to find velocity? I don't remember what it was, but it looked good to me. Velocity, let's say, was 2, 3, stop, send over there, 3, 5, 3. Bingo, all good. What problem were you having, Colton? Because I ain't see no problem. Besides, you didn't have the brackets. So that's good. All right, cool. Who's next? Who's next? Come on, guys, 1 more minute on the clock. Who's coming next? Who's sending me their program next? I don't don't see no program here coming. Where's the other program coming, guys? Let's go, let's go. Program in. Let me make up no noise on Saturday. Send up the program, please. Let me see some programs. Where's Regine? Where's Katrina? Genobi. Come on, give me some, give me some. Give me something. Give me some programs, oh, give me some programs. All right, so let's look what Adam sent me. Oops. All right, velocity times time. All good, Adam. Well done, well done. Oh, the one I saw was the one on velocity, finding velocity, and it works, Adam. I checked that. That's good. Make sure you guys writing your codes and putting them on the worksheet and submitting your worksheet. Y'all know that. Who's next? Has anybody seen Jade? Oh no, I can't believe it. Jade,
Sir,
give
I'm
me some
working on
program.
something.
Say again.
I'm working on something. Give me a second.
All right, cool, nice. Genobi, where you at? Send me up a program. Send me up a program. Where's my Knox friend from Knox side? Send me a program, please. Send me something, even if it's not working. Send me something. I need something, something. Even if it's not working, send it to me. Let me look at it. All right, come on, 4 minutes, 4 minutes. Where's the program? Program. Colton, where's the program? Where's the program? Come on, guys. right. So please remember to complete those programs. Remember that if you're struggling at one or two of them, send it to me. Send what you have done. I'll take my time and send you some corrections so you can look at how to improve as you're going forward. All right. So don't sit over there and struggle. Remember, it's always good to try and put in your best, but if there is something you're finding challenging, do let me know. Y'all are part of the classroom, WhatsApp classroom group, so you can send me a message there and I will respond to that. I'll also send you the link for this week's class as soon as we're through here, so you can have that to revisit next week. As I told you, next week we're going to be trying to move on to and to do a bit of competition. So come prepare for that. Make sure you have a device that probably work with Excel, maybe, because we'll want to do a little bit more than we have done this week, where that's concerned. So please make sure you come prepare. If you can get a laptop, if you don't have one, get one board, get a computer. Get your parents to invest in one for you, and we will be fine where that is concerned. All right, nice, Josh. I'm seeing that. So well done on that. Well done on that. Well done on that. Make sure you're copying your answers and pasting on the worksheet and turning in that worksheet so that I can revisit and look over them and give you some more detailed feedback other than just the verbal one that you have received today. All right, guys, with that said, I won't take any more of your Saturday. I know people got things to do, and so I'll allow you to leave. Remember to get those programs into me so I can use that to gauge what we're doing. I think I'm going to give you a test shortly, snap test. So make sure you're revisiting the stuff that we've covered so far and you're traveling along with me. All right. Are there any questions before we go? Anybody have any question? Anything not clear? Anything you want me to clarify? None. All right. So with that said, everyone, thank you so much for being here. We will see you in 1 week. Next week, Saturday. I think that's going to be on the 18th. All right. We'll see you then. All right. Take care. See you next week.
Yes, sir.
The next
Bye.
week,